So J is fixed. Tj is a subgroup of G generated by B and NW W such that W in Wj. And let Lj be the Levy subgroup of Pj containing E and also for again J is continued. Let W naught J be the longest element of Wj. Then for W in the Y group, let R plus W denote all those positive roots which are made negative so here R minus is the set of negative roots, and let SW be the intersection of R plus W with S, which means all the simple roots that are made negative by W. And then there's a support of W. All those simple roots, such that the corresponding simple reflection is less than or equal to W in the Brouillard-Chevalier order. And we have let Rho be opsum of all positive roots. And the dot action for W in W, let W dot lambda is equal, okay, and what is lambda? Lambda in xt or W dot lambda is W of lambda plus rho minus rho. When W is identity, it is simply the usual action. And so I think more or less the notations are over. I think we can get on to, when I need more notation, I will say. So far, regarding the notation, is there any question or I can proceed? Yeah. So the first thing is Fourier well bought. One more definition I want. Okay. Another minute. Lambda in xt is said to be singular if 2 times lambda comma alpha, alpha comma alpha, 0, or some positive root. So this is the form on the XT tensor R, induced by the killing form of the D-algebra of E. And this is the thing, now the theorem. Yeah. Okay, so I will write the theorem there because it's after the notation. But yeah. Yes. Lambda b. XT. 1 if lambda plus rho is singular, then all the cohomologies varies where L lambda is the line bundle associated to the character lambda of T. So if assume that lambda plus rho is not singular, then we have H L phi of G mod B, L lambda, first H J, G mod B L lambda is 0 for all J not equal to length of phi and H L of phi G mod B L lambda is the global sections of the line bundle given by phi dot lambda, where P is the unique element of W such that P dot lambda is dominant. So this would be non-zero because P dot lambda is non-dominant. This has G modules. And because of lambda plus rho is not singular, there is a unique element which take C. And the other cohomologies vanish. So from here, this is the starting point. From here, so we have Schubert varieties. Oh, sorry, I would have told what is G mod B and yeah. G mod B. Oh, maybe I will restart from here. I think maybe, yeah, phi is the unique element of the while group, such that phi dot lambda is dominant. Maybe I will come back. Maybe I will use till then. That's fine, no, because. So we have, okay, so the flag variety is there. That one is the full flag variety. of all Fourier systems. Now for W, in W, let XW is a scheme theoretic closure inside the full Frank variety. Now, these are interesting varieties. I mean, these are B stable and so T stable. And now here in the case of Borel-Watt, the only one cohomology survives in the non-singular case. And that particular cohomology is given as identified with the global sections of dominant global sections of line bundle given by dominant character of T. So is there any such thing for Schubert variety? That means given a character of B, say such that P dot lambda is dominant, then is there a unique cohomology on Schubert variety which is non-zero? So this is the question. So the question is given two elements of the Y group. Let lambda be a character of this thing, be such that P dot lambda is dominant. So in particular, I assume lambda is lambda plus rho is non-singular, dominant. Then is there unique non-vanishing cohomology? That I mean Hj of xw comma L lambda is 0 for all j different from I naught. Yeah, that one. But that is not true. I mean, the answer will be negative. We will see in sometimes later. And so there are some developments. First, corresponding to the I not equal to 0 case, there is a result or Brodsky, dipolo, independently. Let lambda be a regular weight. That means not singular, non-singular, right? That's of T. And let W is an element of the group. Let PB, that's the unique element. That's that. P of lambda is dominant. Okay, so I think I have defined R plus, yeah. Okay, so such that P of lambda is dominant, then the global sections is non-zero. non-zero if and only if R plus of W intersection R plus of P is the empty set. It's the empty set. This non-singularity is not very important. If it is singular, I mean, we can go to the parabolic. Instead of G mod B, that line bundle will be some suitable parabolic. And then, so instead of W, I should say W upper lambda or something. So I don't want to get into too much of notation. So just I will assume the regular case and get it. So the influence of Borel-Bart and this thing. So given two elements of the while group, one representing the Schubert variety, the other representing where the weight lambda in the chamber defined by phi is there. So the two elements of the while group, W and phi. So with the combinatorics of the combinatorics between the two elements of the while group and the non-vanishing or vanishing cohomology. And not only that, as all these cohomologies are B modules, so what are they as B modules and what are they as T modules? For example, the Dimazur character formula will give the Euler characteristic of the alignment given by lambda, but not the individual character of individual cohomologies. Because in the G mod B case, only one case. So it comes from the Weil's character formula. But for Schubert varieties, as we could see now, there are cases where there may be at least two cohomologies that are non-zero. So this work with let lambda first let W be an element of the while group and phi also be an element of the while group. Let assume that the support of W is the whole set of simple roots. Otherwise, we will reduce to a smaller G mod B. Let lambda be a character such that we would say generic generic weight such that P dot lambda is dominant. Sorry. Okay. Yeah. Let W be equal to phi in the question as above. That is, we are given two elements of while group. So I take they are same. In that case itself, we will see then the support of W equal to S. So whether this is P is nothing but W itself, dominant. By generic, I mean, given any weight is in one of the chamber of the one of the while chamber, and this is interior, not in the boundary. So maybe much bigger, not just regular. It's even more than that. So then, in this case, the result says that if I is unique, there is a unique non-vanishing cohomology. Which I naught of XW lambda is non-zero. By that I mean for j different from I naught, Hj is 0. Then XW is a full flag variety. We know that G mod B itself is a Schubert variety. X of W naught will be that. And I naught equal to length of W naught. Length of W, which is length of W naught. See, because we are in the case W equal to P. So it's a negative dominant weight. So this is the result. And there are more results like given phi and W and phi, there may be other results also, even P and W, such that, I mean, as in the question, problem, do this thing, then XW, the cohomology L phi, XW, L lambda is non-zero if and only if P is less than or equal to W in the Kuhn-Savali order. And then we also have Dabrowski Polo, this thing. This is about the global sequence. So this is the least index for which cohomology is non-zero, because negative cohomology is 0. So this is exactly this thing. And this is the topmost. Maybe there is another result here. First of all, that is just Hj of any Schubert variety L lambda equals 0 for all j greater than L phi. So the cohomology's index will be only less than or equal to, and this is therefore the maximal one, maximum index for which it is true. You see? So now these two tempted this one, that is this thing, and this is the top, tempted to ask some question. So in this regard, we have, let's start with WP, as in the question. So this can be any W, okay, any this thing. You don't have to, the first part is nothing to do with cohomology, right? This thing. Let W plus W comma phi be all those elements in the while group that are less than or equal to W in the Bourgeois order, and R plus of tau is contained in R plus of phi. So some of this related to this, and let let W minus all those taus less than or equal to W and R plus of tau intersection R plus of P is empty. So this is something like for least one, because in this case non-zero if and only if this intersection is empty. So that this thing, and this corresponds to the top cohomology is the length of tau or the minimum of length of tau and length of V. Okay. So now there is a unique element tau plus unique maximal element tau plus of W comma P in W plus of W comma V respectively tau minus W comma P mean W minus W comma P. Okay. Yeah, this is the result. This I have proved, but possibly this result would have been known before. So this lemma. So, but the main result attempting from this kind of thing and from here. Let WB, be as the question. So we have a pair of wide group elements, and then let lambda be a generic weight such that P dot lambda is dominant. Then we have the following. The first thing is Hj, the Schubert variety, so by the line bundle. See, 0 for all j bigger than length of tau plus W comma P to this just H L tau plus of W comma P XW lambda is non-zero. Hj of XW L lambda 0 for all j less than length of W minus length of tau minus of W comma P. These two index is helpful in this way. And fourth, this is slightly a twist here. It's not L lambda. It is the sheaf given by the boundary divisor of the Schubert variety. H L W minus L tau minus of W comma P of XW comma L O of lambda minus D is non-zero, where D is the boundary divisor of XW. And when XW is smooth or going to something that that will be a line bundle. So this thing, so it's up to the twist. So this kind of situation is there now. That from the very beginning of this Borel-Bart's theorem, we have only one cohomology. At most one cohomology is non-zero, and that is non-zero if and only if that is the lambda plus rho is non-singular. So now we assume in the lambda be a generic weight, and so we have these kind of results. Now even that question, just given on W, when under what combinatorial conditions of W and Phi, there is a unique cohomology which is non-zero, is not clear, except G mod B itself is a Schubert variety. For other Schubert varieties, it's not clear, and for which even from that result, there are at least two cohomologies which non-zero when W equal to P. On the other hand, given a W, what are the P's for which the generic lambda in the P chamber, there is a unique cohomology which is non-zero, and what is the B module or a T module, that one to describe. And so this thing will have the top P dot lambda will be the highest weight. This module is a cyclic module as a B module, and the weight will be P dot lambda. That one will be there. Okay, so this so now for the uniqueness, we just try to recently we just try to see we have done some work with Milen and Pranay Saga. So in that context, we look for only some special Schubert varieties. So before that, just the results. Sorry, is there any question so far? The theorem is that WB and A be a subset of S of W inverse. There is all those simple roots that are made negative by W inverse. And note that in this case, XW is PJ stable, PJ, the parabolic PJ stable. In particular, it is the Levi subgroup LJ stable. I don't know if I define LJ, this thing is there. So then XW is an LJ horospherical variety if and only if I stop here. Maybe this statement alone I can can I use this? Can I use this? Just finish the statement, then I. If only if I write in very big letters so that yeah. Or some Kakshitra type element. T such that support of C intersection J is empty. So the LJ is the Lebesgue subgroup of PJ, the parabolic subgroup containing T, and then this therefore this XW is a LJ variety, and horospherical means the horospherical for a reductive group. L acting on a variety X, maybe nice conditions, normality or this thing. This thing, X is said to be this I can go this side. This I can write there, that's no problem. I have some more time. 5 minutes. 8 minutes, huh? Thank you. So that is a plus of this thing, the horospherical. For a reductive group, L acting on a variety X morphically X is said to be horospherical if there is a G-stable open subset of the form E mod H is an orbit such that H contains a maximal unipotent subgroup of G. Sorry, subgroup of L. This is not G mod H, this is L mod H. From the beginning G, now I have changed. For this definition, L, L mod H is that H contains a maximal unipotent subgroup of L. So that horospherical variety, I think is, that result is already there. That if and only if it's of the form this thing. So now let us take horospherical variety. this result, let will be W and J be a subset of S of W inverse. Assume that XW is an LJ Horospherical variety. Then we have okay. So we can write W go to W naught J times C or some Baxter type element. W such that A intersection support of C is empty, follows from the earlier result. This thing, then okay, let P be an element of the while group is such that P is less than or equal to W. Then L phi, that is also then L phi is the unique integer for which X L phi, the unique integer I naught, for which thing and lambda be a generic weight. Such that P dot lambda is dominant. Xi dot XW, L of lambda is non-zero. Sorry. Yeah. Thank you. H, yeah, the cohomology H. This is, thank you. So this thing XW lambda is non-zero. If and only if support of C1. Oh, such a okay, fine. I have to write some notation, just that is fine. I did it just 2 minutes. That since we can write like this, we can write this P is W. We can write P equal to W1C1 for some W1 in WJ and E1 is W such that E1 is less than or equal to E in the Burgas-Savary order. Then, and of course, lambda is already a generic weight in the P chamber. Then L phi is the unique integer with non-negative integer. Not such that the cohomology XW is non-zero if and only if support of E1 is contained in S of C and every element of R plus of W1 is orthogonal to every element of support of C. Yeah, and the result is true when phi is less than or equal to W, and if 1 and 2 holds, then the uniqueness is also true for general phi. But if phi is the unique thing, then that need not be true. The other implication. So only one side in general for arbitrary phi instead of, so because we are assuming phi less than or equal to W, for arbitrary phi, only one direction is true. This implies, and the other direction is not necessarily true. Yeah, that is the thing. There are lots of questions, but yeah, we have to work. Thank you very much.
Yeah, what is LJ horospherical?
LJ horospherical. So LJ is a reductive group, and I think for a reductive group L, acting on a variety X morphically, X is said to be horospherical if there is a G-stable open subset of a form. It's a homogeneous space. There's a homogeneous space which is a open subset of X, such that a stabilizer or any stabilizer, because they are conjugate, contains a maximal unipotent subgroup of L. So the same thing for LJ. That UJ will be there, which is U intersects in LJ.
Other questions? If not, let's thank the speaker again.